So, in the previous video we saw that if in 3000 revolution the crankshaft is taking, so in 1 millisecond it will go 18 degree. Okay. So, this is to be kept in mind that in 1 millisecond it has to go 18 degree. So, let us assume the spark plug is at the center of the cylinder. So, the time taken by the spark to reach the end of the cylinder will be. So, we all think that spark is instantaneous, means it happens instantly, but it takes time. So, when we go and see it in the combustion chamber, is the speed of spark is 2230 centimeter per second. So, it is universally proved that the speed of spark is 2230 centimeter per second. So, let cylinder diameter be 75 mm. Let our cylinder diameter be 75 mm. So, if we calculate the time taken by the spark to reach the wall of the cylinder it is coming to 1.68 millisecond. So, the spark takes 1.68 millisecond to reach the end of the wall. That means, when the spark occurs after 1.68 millisecond, the full power is achieved. Means, when the spark occurs after 1.68 millisecond, the piston should be at 5 degree TDC. So, now let us see in 1.68 millisecond how much will our crank travel. So, final results of the spark and fuel theory. So, by this theory we come to the conclusion that the time taken by the spark to reach the cylinder is 1.68 millisecond. So, in 1 millisecond the crank travel 18 degree. So, in 1.68 millisecond the crank travel 30.24 degree. So, yes, if we have to achieve the maximum power at 5 degree after TDC, then we have to crank the crankshaft 30.24 degree before your 5 degree after TDC, that is 25 degree before TDC. So, as you saw in this thing, this is the real valve timing diagram or the practical valve timing diagram. So, when spark occurs here, the spark occurs here 35 degree before TDC. Okay. So, we have proved the theoretical valve timing diagram wrong, as the spark occurs 35 degree, 25 to 35 degree before TDC. So, now you all are clear that how the ECU work and what it does. Now, what is the need of ECU system? Why the ECU system is needed in the motorcycle system? So, first, to control the ignition timing. Now, only we saw how the ECU controls the ignition timing. It optimizes the timing of ignition according to vehicle RPM. Second is the air fuel ratio. It optimizes the petrol delivery according to the air intake. It controls the fuel according to the intake of the air. Engine temperature monitoring. It monitors the temperature of the engine and alert when hot. ABS system. To function the ABS system by coordinating between front and rear pulse sensor. So, what a pulse sensor? The sensors the speed or the pulse of the rear wheel and front wheel, and the ABS system is functioned by the ECU by knowing the values of this pulse sensor. Pollution control. As it controls the air fuel ratio, so it controls the pollution released in the atmosphere. Traction control. So, as you know, in the ABS system, the ECU controls the speed of both the wheels. So, it knows when one wheel is moving faster than the other wheel. So, when that happens, the ECU controls the ABS system and actuates the brake, so that the traction of the tires and the roads will get maintained. That is how it controls the traction of the motorcycle on the road. Vehicle health monitoring. The ECU stores the data from each sensor and keep a health report of the motorcycle. So, by diagnosing the ECU, we can know the health of the bike. Ride-by-wire technology. So, this is a very new technology, ride-by-wire technology. So, this technology helps the throttle to be connected with a wire only. Now, the throttle will send the signal to the ECU and the ECU will control the fuel delivery. So, these are the needs of the ECU system. Now, we are going to see what is the FI system is. Fuel injection is the introduction of fuel in an internal combustion engine, most commonly automotive engines, by the means of an injector. All diesel engine use fuel injection by design. Gas engine can use gasoline direct injection, where the fuel is directly delivered into the combustion chamber, or indirect injection, where the fuel is mixed with air before the intake stroke. On petrol engines, fuel injection replaced carburetor from the 1980s onward. The primary difference between carburation and the fuel injection is that fuel injection atomizes the fuel through a small nozzle under high pressure, while a carburetor relies on suction created by intake air accelerated through a venturi tube to draw the fuel into the air stream. Now, this is the ECU and the sensors and actuators connected to it. In the left side, you can see the T-map sensor, coolant temperature sensor, exhaust gas oxygen sensor, crankshaft position sensor, camshaft position sensor, detonation sensor, and the battery is also connected to it. So, these are all the sensors that are connected to your ECU system. In the right side, you can see the actuators. So, what are these actuators? The actuators are the devices which actually performs the work. So, one actuator is the fuel injector. So, what is a fuel injector? It injects the fuel into the vehicle. And the second actuator we have is the ignition coil. The ignition coil, what it does, the ignition coil provides the current to the spark plug. Now, spark plug current means it is a current, it device which step ups the voltage of the spark plug, means increase the voltage of the spark plug. Okay. So, this is the diagrammatic view of the different sensors and actuators in a motorcycle. The first is the intake air pressure sensor. So, intake air pressure sensor senses the pressure of the air at the point of the carburetor. So, it senses the intake air pressure, the intake air temperature sensor. So, intake air temperature sensor senses the temperature of the intake air. So, now by sensing the pressure and temperature, the ECU can know the volume of the air entering inside the engine. Third is the throttle position sensor. Throttle position sensor senses the condition at which the vehicle is riding on, whether it is at slow speed, medium speed or high speed. So, according to that, the fuel delivery can be done by the ECU. Second is the fuel cut sensor. So, fuel cut sensor is used to cut the fuel line when the vehicle is in a accidental condition. So, what it does, when your vehicle falls down, it cuts the fuel supply so that the engine can be stopped. Third sensor is the engine temperature sensor. So, engine temperature sensor senses the temperature at the cylinder, which is the maximum hot place, and gives the alert when the engine is too hot. Crankshaft position sensor. This sensor senses the position of the crankshaft. By this sensor, we can know that at how much degree the crankshaft is rotating. Oxygen sensor. Oxygen sensor senses the oxygen level at the exhaust gas. Now, when there is oxygen found in the exhaust, that means improper combustion happens. So, to control this improper combustion, the ECU regulates the air fuel mixture. So, these are the all sensors used in the engine. W, where it is written W, that is your actuator, that is your discharge pump, which injects the fuel inside the engine. The second actuator is the ignition coil. So, ignition coil, it takes 12 volt of current from the ECU and supplies 12,000 volt to the spark plug. Okay, yes, 12 volt to 12,000 volt.